Hello everyone. Today we are going to discuss smart water monitoring system project. On the hardware side, we have the LCD screen, the NodeMCU Wi-Fi board, relay board and ultrasonic sensor connected with NodeMCU board, water pump and an empty box. In this project, we will monitor the status of the water tank, whether it is empty, full or half. The information will be sensed by the water level will be sensed by the ultrasonic sensor. So this part will be fitted inside the water tank to measure the its emptiness and whether it is full or half full. This one is our receiver part that will receive the information regarding the emptiness or whether it is full or half, and it will show it on the screen. These both devices will communicate using Wi-Fi protocol. One will act as a server, another one will act as a client. So this is a server client application and they will use using web server applications. Here we have taken a container full of water. This will act as a storage tank, and this is our water tank. It is presently empty. So when water is not there, it is empty, the pump will start filling the water automatically. So that's a smart monitoring project. It will show the emptiness and also if it is full or half, and also it will automatically start the motor to fill the tank when it gets empty. We also have an LED and buzzer. The buzzer will indicate the emptiness and the LED will indicate when the tank is full. Now we will understand the code. We have two codes, one for the transmitter and one for the receiver. The transmitter will be fitted inside the water tank to measure the emptiness, and this will be the receiver part. So first we will discuss about the transmitter. In transmitter we have included the libraries for ESP communication. This one is the Node MCU board. This is the ESP chip. So we need the ESP libraries for the Wi-Fi communication. So we also have used a ultrasonic in the transmitter unit to measure the distance of the water. These are the pins for the ultrasonic sensor. Trigger pin is connected at D3 of the NodeMCU. Echo pin of the ultrasonic is connected with the D4 of the NodeMCU board. The transmitter unit will create an access point. Access point is like a router, a Wi-Fi connection, a Wi-Fi hotspot. So we have given it a name, SSID name and a password. The IP address, we have assigned the IP address, a gateway address, a subnet address. So these all are Wi-Fi credentials, Wi-Fi related informations. These are two variables that we have declared to calculate the ultrasonic distance. An empty string. This is the function where we will calculate the distance of the water using ultrasonic sensor. So this is the calculation method. First we transmit a pulse using digital write. Then we wait for 2 microseconds. Then we transmit a high pulse. First we transmitted a low pulse for 2 microseconds, then a high pulse for 10 microseconds. Then we switch off the pulse. Then we will receive the pulse using pulse-in method at the echo pin, and we will calculate we store the duration of the pulse, the time that pulse take to travel forth and back. So this is the formula for calculate the distance. If we have the duration, we can calculate the distance by using this formula. So this, by this ultrasonic function, we can have the distance that we are measuring. Now the setup function. In setup function, we have declared the trigger and echo pin of the ultrasonic connections. Next, we have initialized the Wi-Fi as Wi-Fi access point, a delay. Then we have configured the Wi-Fi, IP, gateway, subnet, SSID and password. Now loop. Inside the loop, we have initialized the server to handle the client and to transmit the information to the client. This transmitter is acting as a server and the receiver will act as a client. So the transmitter is a server. We have created a server, or we can call it access point or a web server or a hotspot. So the information we need to transmit to the client is ultrasonic sensor information, the distance. So inside the server.on function, we have first call the ultrasonic function that we have declared above. So first we have called the ultrasonic function to measure the distance. Then we have created a web string, and inside the web string we have stored the distance that we calculated by using the above function. Then we have called server.send to send the web string to the client. So this is the server, this is the client. And server.begin will send all the data that we have given here to the client. So this was all about the server code or transmitter code. Now we will understand the receiver part. So this one is the receiver code. On the receiver side, we have LCD, NodeMCU board, buzzer, LED, relay board, motor. So the first connections are for the LCD screen. D0 will be connected to the RST, D1 to CE, D7 to DIN, D6 to DC, D5 to clock. So these are the connections for between the NodeMCU board and LCD board. Next, we have included the ESP library, serial peripheral interface library for communication with the LCD. Then we have included the Adafruit graphics library for displaying text information on the screen. Next, we have the HTTP client library because this device will be act as a client. So we need this library, and web server library to communicate with the server. These are Wi-Fi credentials. These credentials are same and should be matched between the transmitter and receiver. We have created a server object to communicate with the server. These are the pin connections declaration for the Adafruit library to initialize the LCD screen. We have used an LED at pin number 4 or D2 pin, relay at pin number 2, D4, 0, buzzer it at 0 or D3. So we can call it GPIO4 or we can also call it D2. GPIO2 or D4, these are same. GPIO0 or D3. Inside the void setup, we have first begin the display LCD, then clear it, then set contrast. Then we have declared the pins for the LED and relay as output pins. Then we have by default first activate the relay. As this relay board is an active low, that means it will switch on the motor when a low pulse is transmitted to the relay board. So we have by default make it high. When we will make it low, then it will get on. buzzer output pin, Wi-Fi as a station mode. In in this we have declared the Wi-Fi as access point, but in this we have declared the Wi-Fi as station. Wi-Fi begin with the SSID and password. Here we are trying to connect to the server. The connecting information will be displayed to the screen. Next, if it get connected to a server, it will display the SSID on the screen. We will see it in the screen in a few moments. Inside the loop, we will first clear the display screen, then we will create HTTP client, begin the communication with the server. This is the server address that we provided in the transmitter code. We are getting the information using http.get command. This is a needed statement. So next after getting the HTTP's data, we are checking if the data is non-empty. If the data is non-empty, we will we will extract the information from the data. The data will be in format of like distance, the value and centimeter. So we need the value. So we will discard the distance text and the centimeter text. We will extract the value from that information. So these statements are for the extraction of the value. After extracting value, we will come here. We have stored the value and converted into an integer. So the value will be between 0 and around 300 centimeter. This is the level of the water. It's a digital value, and we will compare it. And according to the value, we will determine if tank is full, empty, or half. If the value is less than 12, it means tank is full. We will display it on the screen, and we will make the relay off. Buzzer will be off, and LED will be high to indicate the fullness of the water. Next, if the value is between 12 and 27, that means tank is 3/4 full. Next, if the value is between 27 and 55, the tank is half full. Next, if value is between 55 and 300, that means tank is empty. All the information will be displayed on the screen. If the tank is empty, we will switch on the buzzer, and we will also switch on the relay. After getting the information, we will close the connection, and this all statements, this all will be go on and on inside the loop. This was about the code. Now we will see the functioning of the devices. First, we need to upload the code to the transmitter as well as the receiver. First, we'll upload the receiver code. The receiver device is connected with a USB cable to the PC. We need to first check the board. Board should be NodeMCU ESP12E. COM port should be the port number at which the board is connected. Now we will click on upload. Uploading is done. Now we'll upload the transmitter code. Tools, board. We will connect the board to the PC. We will first connect the board to the PC. Now we will upload the code. Now it is uploading the code. You can see the blue LED on the device. It is on. Done uploading. Now we can disconnect the cable. We need to power this module and the ultrasonic sensor with a 5 volt. So for to power this module, we will need the Arduino board. This board only provides 3.3 volt, so we cannot power the ultrasonic sensor with a 3.3 volt. So the power purpose, we will use a Arduino board for the 5 volt power supply. So we will disconnect the USB cable. We will take Arduino board. We will use the 5 volt supply of the Arduino board. The 5 volt supply from the Arduino board will go to the V-in pin of the NodeMCU board, and another 5 volt to the VCC pin of the ultrasonic sensor, and all the ground connections will be common. So connections are done. Now we can plug the USB cable. Now we will connect the USB cable of the Arduino to power the Arduino as well as the module. Now we'll switch on the receiver as well by plugging the USB cable. If the transmitter has started successfully, we can see it on a Wi-Fi communication window of our PC. This is the Wi-Fi communication window of our PC. We have created a hotspot on the transmitter end with the name of Save Water, so we can see it on our PC. So transmitter is working correctly. Now we will see the demonstration of the project. So we are done with the setup. This is the transmitter that will measure the level of the water, and this is an empty tank. This is the water storage tank, motor, LCD. The messages will be displayed on the LCD, relay board, the buzzer, the LED. So now we'll see the demonstration. And presently it is showing us an empty signal with a buzzer. We are giving a signal with our hand. Now an LED has been on. LED is on, indicating that water tank is full. We are creating a water level using our hand. The messages, it is showing us LED indication. That means it is the LED shows us an full indication. The messages can also be seen on the screen. Tank is full. We can see a message of full, half full, three-fourth full, and if we increase the distance, it will show an empty status. So now it is empty and the water pump has been started. It is filling the tank. The buzzer indicates an empty state. So this was about the smart water monitoring project. We can see the messages on the screen as well. So this was the LCD screen on which the information was shown. Thank you.